This is lesson 5048, where we are looking at the nth term rules for sequences of patterns. In this first example, you are told that n stands for the position number, which is written here. And then the first rule has been written in an algebraic form as well. So the rule is that you add 3 to the position number. So n plus 3. So you've got to come up with the algebraic term for this rule, which is multiply the position number by 4. Now when we first started learning about algebra, we said that that means n is being multiplied by 4, so it's n times 4. But we all know that this can be written a little bit nicer, so that's the same as 4n. So in algebraic terms, multiplying the pattern number by 4 is the same as 4n. The next example is about a pattern made of dots. And the first question is, complete the rule for pattern A. So pattern A says the number of dots is equal to something multiplied by the pattern number. Now the pattern number is 1. What do I multiply 1 by to get 2? So 1 times by a number has to be 2. Then here, 2 times by hopefully the same number has to be 4. And then you get the idea. That has to be 6. So all of these missing numbers are the same. 1 times 2 is 2, 2 times 2 is 4, and 3 times 2 is 6. And it will work here as well. 4 times 2 is 8 dots. So this missing number here is 2. The second pattern of dots, pattern B, builds on the first one. If you notice, there are slightly different colors here. There's always 3 extra dots. So if you go back here, the number of dots will be something times by the pattern number plus another number. So we started with the 2 times the pattern number. That works because these darker dots match pattern A. And then the additional extra dots will be in this grey colour, which is always an extra 3, therefore you add on 3. And there is one more example where we start looking at the nth term rule for the patterns. That's this one. So you can see that there's a matchstick pattern here. The question is, how many sticks are added to the pattern each time? So this is our initial pattern. When you look, it's these sticks that are added to it. So that's 1, 2, 3, and 4. So the answer for question A is that there are 4 matchsticks added to each pattern. And it works here as well. Look, that was the previous pattern. 1, 2, 3, 4 additional matchsticks. Question B is, find an expression for the number of sticks in the nth pattern. In other words, you need to find the nth term rule for this pattern. Now before we can do that, if it's not already done, like it is here, you need to turn your pattern into a sequence of numbers, which means you just count the matchsticks, the dots, whatever the pattern gives you. So you've got 1, 2, 3, 4, 5, 6, 7, and look, 7 is there already. This one counted gives you 11, and then again gives you 15. So now we're just looking at the nth term rule for 7, 11, 15. So first of all, you will find what the rule is from one number to the next, so the term to term rule. This one is add 4 and add 4. Now from last week's topic, when you looked at how to find the nth term rule, you will know that this means that we are going to connect this sequence to the 4 times table. So therefore we're going to start the nth term rule with 4n. So this 4n represents the 4 times table. But if I put the 4 times table above the sequence, 4, 8, 12, you will notice that it doesn't match the sequence. From 4 to 7, I've got to add on 3. From 8 to 11, I've got to add on 3 as well. And luckily it works for the last pair of numbers. From 12 to 15, I add on 3 as well. So what this means is that rather than having the 4 times table, the sequence is always 3 greater than the 4 times table. So the nth term rule, or the expression of the number of sticks in the nth pattern, is going to be 4n and adding on 3. Remember from the first example, n is the position number. And if I look at, for example, the second, so n is 2, then 4 times 2 is 8, plus 3 is 11. So the second one has 11 sticks. So I can put 4n plus 3 in here. And the last question is, use the expression for finding the 11th pattern stick numbers. So that means that we are going to, for the 11th, n is equal to 11. And then all you have to do is substitute this number into the expression. So 4n, remember, means 4 times n. So when n is 11, that means 4 times 11. And then plus 3. So that equals 44 plus 3. So it equals 47. So there are 47 sticks in pattern 11. If you wanted the 50th pattern, then you would be looking at 4 times 50 plus 3. If you wanted the 100th pattern, it's 4 times 100 plus 3, and so on.